We have one more section in this chapter. 8 sections. That's exciting, isn't it? Because that means the test is going to be over 8 sections. Questions?
Yes. So many. Can you get homework on this?
So, some of you, in fact, a vast majority of you, are going to be gone just playing around. I don't know. You're going to be God, sharing a play that has a very good moral. I appreciated very much the moral of that story of that play that you guys had. Now, those who are gone, I have good news. You will have no geometry today while you are gone.
Yeah, thank you, Mr. Fisher. I was so worried about that.
Now, those of us who are here, I have equally good news for you. Yes, we will have class, and yes, we will have geometry to work on. So, those are the two. All right. And when you come back, will be the review and the test. So
Yes. Are we gonna have like a
yes, you do have to take the test. Section 8, Chapter 10, Section 8, the last section here of this chapter. We have been studying circles, relationships of arcs and angles and segment lengths, all sorts of stuff. Now we are going to look at the algebra of the circle itself, the equation of the circle itself.
Yes.
Now let's start back with the definition of what a circle is. It's the set of points in a plane, so we're two-dimensional, that are equidistant from one point, which we call the center. And that distance is called the radius. And the distance formula, equating the distance to the radius, is where the equation of the circle comes from. So if you think of the circle they have drawn right here, whose center is right at the origin, then every point on that circle has some x and y value. And it doesn't matter where it is, I could draw a nice little right triangle that represents my x distance and the y distance to get to that point, and connecting it with the hypotenuse, what happens to be the radius right over here. And we know there is a relationship in a right triangle between the side lengths and the hypotenuse length, called the what theorem? Pythagorean theorem, called the Pythagorean theorem. David, what's the Pythagorean theorem?
Oh, it's 2 legs squared and it equals the hypotenuse squared.
If we take the square of each leg, add them together, the sum of the squares of the lengths of the legs equals the square of the length of the hypotenuse. So right up here, that's all they have written out. X squared, that's one leg side of the triangle, plus y squared, the other leg side of the triangle, equals r squared, that's right over here, the distance between the center and that point on the circle. So this is the simplest equation of a circle that is centered right at the origin. Very easy. So if I come right down here, they are now going to say, well, what if I move the center to a new spot? So they're going to say this new spot for the center is h comma k. It's just an ordered pair, but we're using different letters, h comma k. Well, then I'm going to apply the distance formula, because the distance from the center to any point on the circle, also called the radius, well, we know the distance formula, I think. The square root of x x of 2
plus x
minus x of 1 squared. There we go. There's the distance formula. So let me replace d with r, because the distance from the center to the side of the circle is called the radius. I'm just going to replace that distance with r. And then I am going to replace the x of 2's and x of 1's with these letters over here. I'm going to go x minus h. So that's like my x of 2 minus my x of 1, x minus h, quantity squared. Then I'm going to go y minus the k, the quantity squared. So this is simply the distance formula, is all I have written down. But replace the letters with the ones that stand for the values in my circle. Now I'm going to get rid of a square root. How do you get rid of a square root? You square. I have to square both sides. So if I square this r, it becomes r squared. And I'm going to write it on the right side. And if I square the square root, it's just gone. X minus h quantity squared plus y minus k quantity squared. Now, where did I get this formula from?
You just took away
The distance formula. And just replace the letters with the letters that work with our circle. I just got it from the distance formula. Look right there. The equation of a circle, called the standard form of the equation of a circle, with center at h comma k, is this. It's that thing we came up with right there. So.
Okay, well, why can't you cancel it out? Because you already have...
Cancel
like
out. Cancel what?
Yeah,
The
never mind.
squares?
Yeah, because there's like the square root, and then you already
Because you
have the square root.
cannot eliminate the squares when they're part of a sum. What you can do, if I had the square root of just x squared, that's x. That's okay. You can do that. But if I have the square root of x squared plus y squared, I can do nothing with that. I can't eliminate the squares in that case because it's a sum in there. All right. So that's why. So it has to remain squared still. So you want to memorize this nice equation right up there. It's easy enough. So let's look at these questions. Write the equation of each circle. It says the center is at 1, negative 8, and the radius happens to be 7. Well, let me go ahead and write this thing down because you probably don't quite have it memorized, but real quickly you will. X minus h squared plus y minus k quantity squared equals r squared, the radius squared. So I'm going to fill in the values. I'm going to say x minus 1, quantity squared, plus y minus a negative 8. Now what happens when you subtract a negative? Yeah. Quantity squared. 7 squared. What's 7 squared?
49.
There it is. We just wrote the standard form of the equation of that circle. Easy. Easy, easy. It says the circle graphed at the right. We're supposed to write the equation of that thing. Well, there's really only two things we need to know. We need to know where the center is, and we need to know what the radius is. And as soon as I know those two things, it's easy to write the equation. Where's the center of that circle?
0, 4.
0, 4. Can you tell me what the radius of that circle is? 3. How'd you get 3?
Minus 4.
Yeah. 0, 4 is the center. 0, 7 is a point on it. The distance between those is 3. That's how you got 3. 7 minus 4 is 3. Why do I just have x squared?
Where did the 9 come from?
Well, it's not plus 0, it's minus 0. X minus h. X minus 0. X. X squared. Then y minus 4 equals, why is it 9? 3 squared is why it's 9. So
you just leave it like that?
yeah, that's it. That's the equation of a circle. It's in standard form. There's other ways it can be rearranged, but that's the standard form of it. And that's what we're working with, is the standard form. Let me ask you, what is the center of this circle that I wrote the standard form of the equation for? Negative 3, comma 7.
Oh, and the radius.
We're always subtracting the h value, subtracting the, excuse me, k value, which really means it's just going to be the opposite sign. If I see a negative 1 there, it means it's a positive 1. If I see a positive 8 here, it means it's a negative 8. So when I see x plus 3, it's a negative 3, y minus 7, positive 7, negative 3 comma 7. What's the radius? 8. 8. Circles are easy. Write the equation of the circle. The center is here. It happens to pass through this point. Now, often making a little sketch is helpful for us. This one, it's actually not going to be, but I want to do the sketch of it anyway. Negative 2, 4. If I go back 2 and up 4, so I have this point right here, center. Negative 2, comma 4. And then negative 6, 7 is a point. Negative 6, comma 7, so here's another point on the circle at negative 6, comma 7. So we have some sort of circle going like that.
Beautiful.
Well, can you just look at that and tell me what the radius is? No, is the answer to that. Previously, we could. We could just look right over here. Oh, yeah, radius is 3. That was easy to tell.
Yeah.
But this one, you cannot just look at that and say, oh, the radius is, we don't know. So we're just going to fill in the equation. And again, you want to have this all memorized. I'm going to fill in this equation with the numbers that we know. Do I know this x and the y are an x and y point on the circle? Do I know a point on the circle, an x and y?
Yes.
Yeah, a negative 6 and 7. X is negative 6.
6?
6.
I thought that was a 2.
Look right here.
Oh.
Oh. All right, then I'm going to come over here. The y is a 7. So I know an x and I know a y. What do the h and k stand for?
Positive 2 and the
The
negative.
center. So the center is going to be
Positive 2.
plus 2
Negative
and
4.
minus 4. There you go.
Wow.
R stands for the radius. Well, that's what I don't know.
So radius.
So we're going to be able to figure that out real easily here in a minute. Oh, I need to square this, don't I? There we go. What's negative 6 plus 2?
Negative 4. Oh.
Negative 4.
Yep.
Squared. 7 minus 4 is 3 squared.
So you got 9.
So what's negative 4 squared?
16.
16 plus
9.
9. And that's the radius squared. That's 25. 25 equals the radius squared. The radius is 5. But in this case, since they want me to write the equation, then the radius squared is actually what I want. Remember, this is the equation of a circle. Well, x, what was our center? Plus 2, quantity squared, plus y, help me out. Minus 4, quantity squared, equals what? 25. It's supposed to equal the radius squared. We figured out the radius squared was 25. There it is. We got the equation of that circle. Nope, because the equation of a circle only uses the center point and the radius squared. So there's our equation of the circle. And where did I get it from? I used the equation of a circle and I just filled in the numbers that they told me. And that told us what the radius squared was. Also the radius, but the radius squared is the thing that goes on the end. Graph a circle. So let's look at this one. The equation of a circle. Now wait a minute. This equation looks totally different, doesn't it? That is not in standard form. Now we're going to need to get it in the standard form. We'll learn how to do that. You have learned in the past, but we'll get that again. State the coordinates of the center, because we're going to have to figure out where the center is, and the radius. We're going to have to know what the radius is, and then we can graph it. Then it'll be easy to graph that thing. So as I continue to have your attention, if we are going to get this in standard form, it means we are going to have to complete the square so that we get these little perfect square trinomials that factor x minus h squared. Those are factored things. Y minus k squared equals the radius squared. So we have to get those perfect square trinomials that factor is these things. So here's the process. I need to collect my x terms. So my x squared minus the 8x, I want to get it together. And I'm going to go for my y squared. I'm going to leave some space here. Y squared plus 2y. I want those together. I'm going to leave a little space. And it equals a negative 8. Completing the square is that algebra process where we figure out the number that goes here so that this trinomial will factor as some binomial squared. This thing. Who remembers how to get that number? See if you can go back to your Algebra 1 brain from last year. Two different brains. We take half of negative 8. We'll take negative 8 divided by 2, and then we will square it. It was somewhere there. What's negative 8 divided by 2?
-4.
Negative 4. What's negative 4 squared? 16. So a positive 16 is the number that completes the square on this. Now I have an equation. An equation means the two sides are equal. If I add 16 on the left side, what do I need to do on the right side? Add 16. We have to do the same thing to both sides of the equation. Now let's complete the square on the y. This will become a perfect square trinomial, which is going to factor as some binomial squared. It's going to be this part right there. So you go through in your head what I did back here. Tell me what I need to add. 1. Half of 2 is 1. 1 squared is 1. So we take that b value, a, b, c. We take the b value divided by 2 and square it. So 2 divided by 2 is 1. 1 squared is 1. And if I add 1 on the left side, add 1 to the right side. Now these should be factorable. X minus 4 quantity squared. If you took x minus 4 times x minus 4, it would equal this trinomial. Anybody remember how I got that 4? Or the negative 4? Yep. It's just half of this negative 8. Always. This is going to be y plus 1 quantity squared. Because half of 2 is 1. And it's a positive, so that's a positive. If you did y plus 1 times y plus 1, or squared it, it would be this trinomial. Y squared plus 2y plus 1. So we just changed it into its factored form. So we created perfect square trinomials that would factor. Now do all this math on the right side. What does it equal?
9.
9 equals 9. Hey, look at this. That's standard form. Tell me what the center is. 4 comma negative 1. Remember, you just changed the signs there. Tell me what the radius is. 3. 3. Look at that. How did we know the radius was 3? Square root of 9, because that number on the end is the radius squared. So we just take the square root of it.
The only thing you could, okay, so it's always going to be like that. It's always going to be half, and then it's always going to be half of the other one. So that's why there would be x.
Always that pattern.
So the only reason you can get 9 is to figure out the other two numbers.
You just figure out all these numbers together. That's where we got the 9 from. We just added all those numbers together. Now, it is possible, before I go to graph this, it is possible that maybe you'll come up with an answer like this. X minus 2 quantity squared plus y plus 3 quantity squared equals 17. What's the radius of that one? Square root of 17. Sure, you know what the radius is. It's the square root of that number. It's the square root of 17. Now, if you were asked to graph that, you'd have to figure out 4 point whatever it is, so you know about how big it is. But the answer is square root of 17. That's the radius. They don't always end up being integers, but you're smart sophomore, so you can handle that. Let's graph this thing. Center is at 4 comma negative 1. So down over 4, down 1, so there's my center. My radius is 3. So 1, 2, 3, 1, 2, 3, 1, 2, 3. If you have your compass, which you all should have your compass, then it makes it real easy to draw a nice circle, right? So make sure you draw a nice circle. All right. You can do that with your compass. Graphing it, that's easy to do. Easy to graph. For each circle, with the given equation, state the coordinates of the center and the measure of the radius. and then graph. Here is another one that's not in standard form. So we're going to go through that same process. We're going to collect our x's. They're my x terms. I'm going to leave some space. Then my y terms, y squared minus 14y. I'm going to leave some space. And this time I have to subtract 40. I want that number on the other side. So we always want to rearrange it so it's in this order. So help me out with the x's. Complete the square. Tell me the number that goes here.
4. No.
Where did we get 16? 8 divided by 2, and then square it. 8 divided by 2 is 4. 4 squared is 16. And we will remember, if we add 16 on the left, we will add 16 on the right. Tell me the number for this one. 49. Half of negative 14 is negative 7. Square negative 7, you get a positive 49. And we will add 49 to the other side as well. So we have to keep it balanced. Now we will write these in their factored forms. Both of them will be binomials squared. So I want you to tell me what they will be. I'll even do the hard part, put the x in. What is it?
4.
X plus 4. Half of that positive 8. X plus 4 quantity squared.
So it's always going to be it's always going to be one binomial squared instead of 2.
Always.
Yeah.
Always. That's what completing the square does for us. How about the y?
Minus 7.
Y minus 7, quantity squared. What would you get if you took y minus 7 and squared it? You would get y squared minus 14y plus 49. That's what you would get. Equals
25.
to 25?
Yep.
See, that's easy. Tell me what the center is.
Negative 4 plus 6.
Tell me what the radius is.
5.
Look at that. There's the center. Here's the radius. What's our center? Negative 4, 7. So back 4, up 7. And radius of 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Then draw your circle. B. 3 tornado sirens. If you live in this part of the world, you know something about that. Are placed strategically on a circle around the town so that they can be heard by all. Write the equation of the circle on which they are placed. If the coordinates of the sirens are, siren A is at negative 8, 3, negative 8, 3, so there's siren A right here. B is at negative 4, 7. You guys go ahead and put away your keys for me. And C is negative 4, negative 1. So here are 3 sirens. Now those, says write the equation of a circle on which they are placed. Those are supposed to be on a circle. And by the way, any 3 non-collinear points, you can find a circle that goes through them, no matter where those points are. There exists one circle that will go through those points. So how are we going to do this one? Well, this one is actually going to be done graphically with our nice compass. So I am going to connect these 2 points right here, which would be a chord on my circle. I mean, somewhere there's a circle out here. I don't know where it is, but that would be a chord on my circle. Then I'm going to get the perpendicular bisector of that chord. So I'll remind you how we do that. If I want to get the perpendicular bisector of that, I need to start on one end. I have my compass opened up, so it's more than halfway. I'm going to make an arc up here on one side, an arc on the bottom. Then I'm going to take it to the other side and just cross those things. So I'm going to cross that one. Uh-oh. I ran off my page. There we go. I'll probably be off a little bit, but hopefully not too bad. And I'm going to cross this one. And now when I connect those, I'll make a dashed line here. I'll move it over. I kind of got below, so I'll just make it below down here and then slide it up. So when I go through those points, hopefully I'm going through those points pretty good. what do I know about this dashed line in relationship to my circle? See if you can remember some stuff from before break. That is a diameter. It will go through the middle. It will go through the center. That's a diameter. So my center is somewhere on this dashed line. So I'm just going to do the same thing down here. I'm going to make another chord. This will be a chord in our circle. So here's another chord. Let's see if I can adjust it a little so I'm not covering up my stuff. I'm going to do the perpendicular bisector of that thing. Whoops. So I'll come over here, and anytime we're doing it graphically, then the better your picture, the more accurate your answer. So hopefully my picture will be good enough. Go to my other end, and I'll just cross these. So I have, all right, draw a line. There we go. Connect these 2 points. I'll get a little closer on that one. The center should be right there. Tell me the coordinates of that point. Negative 3, comma 3. It looks like my center is at negative 3, comma 3. They say, write the equation of the circle on which these things are going to be placed. Well, I just figured out what the center is. I need to know one more thing.
The radius?
The radius. So like last time, I am just going to fill in x minus h quantity squared, y minus k quantity squared equals the radius squared. And the x and y are one of my points. Doesn't matter which one of the points. I'll just pick point A. So I have a negative 8. And my y is a 3, so I'm just filling in the x and the y. And my h and k are the what? That's the center stuff. So tell me about the number I need down here. Plus 3, minus 3. And that equals the radius squared. Well, what's 3 minus 3? 0. 0 squared is 0, so I don't need to worry about that one. What's negative 8 plus 3?
Negative 5.
Negative 5 squared is 25. 25 equals the radius squared. Hey, that's all the information I know. Write the equation. So you help me out. What's the equation of the circle? X plus 3 squared plus y minus 3 squared equals 25. That should be the equation of the circle. Now, just for fun, let's see how good a job I did, because geometry is always fun. Let's see how good a job I did. If I put my center right there, trying to get it to stop right in that spot. Come on, stop right on that coordinate. That's good enough. And I counted out 1, 2, 3, 4, 5. Hey, that's about 5. Oh! No! That's terrible. I think we did something wrong.
Well, I mean, the radius is 4 just by looking at
Yeah,
it.
you can
So
see.
center to A is 4.
That's what I was thinking.
Negative 3, 3. Right, 1, 2, 3, 4. But let's find the mistake. X is negative 8. Y is 3.
Got in the center or something.
Plus 3. You guys are supposed to find the mistake before I do.
Oh. I was kind of thinking about it.
It might just be where you drew the perpendicular bisector.
Oh, it could be my perpendicular bisectors are not on the right spot.
This is the first thing you messed up in all 2 years.
Yeah, the center should be negative 4, 3. So my perpendicular bisectors were not good enough. So there's the only challenge with the graphical ones. So let's come back. This would be plus 4. What's negative 8 plus 4? Negative 4. Squared is 16, which would change this to 16, which would change this to a 4 right there. And then, if I had a radius of 4, so 1, 2, 3, 4, from the right center,
A is at negative 7.
there's where the whole mistake came from. Negative A3. Negative A3 should be right there.
I was looking at it.
So now you've seen all the things that can go wrong, and you won't make those mistakes. There you go. That's what went wrong. Find the points. Next one. Find the points of intersection between x squared plus y squared equals 4. What shape is this? Let me write it slightly different. What shape is that? That's a circle. Where's the center of that circle? 0, 0.
How do I know that?
This one has a center at 0, 0. How do we know that? Because if I have x minus 0, that's just x. So it just looks like x squared. We saw that earlier, right, Logan? We saw that earlier. Right back over here, this one had a center at 0, 4. Well, if I go x minus 0, that's its x squared. So don't be fooled when you just see x squared or just y squared. It just means a 0 goes with it. So this is a circle with a radius of what? Try that again. 2. Radius of 2. Let's graph that. Let's graph a circle, center at the origin, and the radius is 2. So it's going to look something like this. So if we then look at our next equation, y equals x, what shape is that? You need to go back to your Algebra 1 brain again.
Line.
That is a line. Y equals x is a line. And it also has a plus 0, if you will. What's the y-intercept of this one? 0. The y-intercept is 0. What is the slope of this? 1. Y equals mx plus b. Somewhere in your mind is that?
Oh, yeah.
So y equals x, that's a line. Slope is 1, y-intercept is 0. So if I did a slope of 1, up 1, right 1, up 1, right 1, so I have this line. Now their question was not graph this, but I'm using the graph to help us learn. Their question was, find the intersection. Their point or points, maybe plural. How many intersection points are there between that? There's 2. There are 2 locations, right here and right here. And don't try to read them off the graph. They're not integers. We're going to have to do the algebra. Well, intersection means where the points are the same. The circle and the line, it's the point that is the same. So in algebra, if that's the same, it means they equal. Now I need you guys to focus because you're going to have to do this, so I want you to be able to. So if I am going to solve this, I'm going to take the equation x squared plus y squared equals 4, and I'm going to take the equation y equals x, and we're going to solve it for x and for y. And this is set up for substitution, really. Y equals x, which means every place I see a y, I can replace it with an x. So I'm going to write this equation, x squared plus x squared equals 4. And that would be 2x squared equals 4. And I can divide by 2. X squared equals 2. And then how do I get x instead of x squared? Square root. In fact, I will even remember that I need to go plus or minus square root. There are 2 answers there. Two numbers that you can square and get 2. A positive and a negative. When you square them, you get a positive answer. So there's what x is. It's either a positive square root of 2 or a negative square root of 2. Well, how about y? Well, same thing. Y equals x. A positive and a negative square root of 2. So now I can understand what that location is. That's negative square root of 2, comma, negative square root of 2. It's to the left and down. And what is this point? Positive square root of 2, comma, positive square root of 2. There's the answer to this question. The answer to this is, where does it intersect? It intersects at square root of 2, comma, square root of 2, and at negative square root of 2, comma, negative square root of 2. They're the locations where that one intersects. Assignment 10.8, and I have it printed off for you because part of it is graphing, and I provide the graphs for it.